Okay, we have a cracking the code interview question. It's called Successor and has to deal with a binary search tree. So it's write an algorithm that finds the next node, for example, with an in-order traversal of a given node in a binary search tree. And we can assume that each node has an attribute of a link to its parent. Yeah, so let's just start with this. This is some other things I was dealing with before, trying to figure out how in-order traversal works. This is in order right here. But yeah, so let's just focus on this part right here, which is just the binary search tree. 50 has left and right childs up here, and 25 left and right childs. So let's just say like you're given a node of 17. Like what's the next biggest number in order traversal wise? So it'd be 25 because it's 4, 13, 17, 25. And if you're given 4, you should return 13. If you return 50, you should return. If you're given 50, the next successor is 75. If you're given 60, it's 75. Or actually, wait, if you're given 50, the next number is 60. And if you're given 60, the next number is 75. And if you're given 85, you return none because there is none. Yeah, so it's a little bit tricky problem. At first, like the brute force is just like doing in order traversal. And then you put that all in an array, and then you just add that to an array, and then you just figure out what the next number is after the number, your target that you're looking for. But that would be spacetime clip so you have log n, and then you have to, and also be runtime of log n as well. So it's just like, how can we cleverly traverse this and get to the next number? So it's just that, like, if you're given 17, let's do an easy one. So if you're given a node of just say like 13, the first thing you want to look for is just if it has a right child, and which would be 17, but 17 could have a number of like 14 here. So essentially what it is rule number 1 is you want to look for a right child and the leftmost grandchild on the right side. So this could, like, I mean, 17 could have a node of 16, 16 could have 15, and 15 could have 14, you know, and so it's just one, and it could go, keep going left, 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 you know. So rule number 1 is if the node that you're given has a right child, return its leftmost child in that subtree. Which we have a helper function that does that. It takes in the node, and if the node is known or null, just return that. So while it has a left node, so you give it a particular node, and if it has a left node, you just keep on going left, left until you can't anymore, and then you return that node. So that's leftmost child. So as you can see, the first check we do is no, it's not, it's return none. So here's this, if it has a right child, return the leftmost child, so that's it. Well, that's one case, but here, if you have another case of when you're given 17 and you want to say, hey, what's the next successor, which would be 25? 17 doesn't have a right child, so what you have to do is pretty much work your way back up the tree until you find a parent that to its right. So you go up to 13, and then you have to go 13's parent is 25, which is a right parent, which is kind of key to know. And then you just return that 25. It's kind of a tricky way of, you have to hold many things in your head right now to kind of figure that out. But you do a while loop, you just keep bubbling up until you traverse it, going upward until you haven't traversed a parent node anymore, essentially. So, see, I'm gonna have to cheat and do this. So here's the other case. We've talked about this case. So here's the bubbling up case, or traversing upward case. So you're given you start your node or temp node and its parent. Like I said, Well, there is a parent, and the parent that left isn't the temp node, then you want to just keep on going up. So that's the key thing. You gotta make sure you're going to the right, upward and rightward. So you keep on doing that until these two. Yeah, it's like, so in this case, the temp node 17 and its parent is 13. And 13 has a parent, and its left child isn't 13, and the parent's left child is 13. So yeah, this is where it's good. Well, it has a parent. Well, there is a parent, and the parent dot left doesn't equal the temp node. Yeah, so here's what it would do is it'll make temp node. So 17 would go to 13. So temp node was 17, now it's 13. And then the parent is going to be the parent of the parent, and now the new parent is 25. So parent went from 13 to 25, and then the temp node went 17 to 13. Then you do the same thing again. So this is number 25, so what you want to do is just return the parent, yeah. And parent exists, and parent dot left is 13. And that means those two equal. So then we exit because 25 is the parent, and return 25. Man, that's confusing, but that's the way the algorithm works. So I need to like understand a little bit better of how it. Because your exiting case is when the parent and the left equal each other, and then you would just turn the parent. But in this case, the parent was to the left, so you have to keep on going. But this is your first parent to the right. And that's what you're looking for, the first parent to the right when you're bubbling your way up. And then you would just return that parent. So, yeah, just to prove this works. So let's just say we do the inserter in order succession of the 17th node, which would be 17. So it should return 25. So let's see what it prints. Yeah, 25. So let's say we're given 4, it should be 13. Right? Give it node 4, now it should print 13. What else is another tricky one? So let's do 50, so, which should return 60. Should return 60. And then let's just say we give it the rightmost is 85, and this should return none. Oh, I think I might be missing edge case there. Where I have to. It's calling none. So, huh. So. Huh. Let's figure that out later. But anyways, that's kind of the crux of it. The edge case of when you're given the very most right of the node. Because how this would work is you get node 85, that skips this, and then if it doesn't have a node right, then what it would do is it would skip this because it doesn't have a right. Anyway, well, that's that. Now I just have to put in the edge case of when you're given the very last node in the binary search tree, they return none. Yeah, because so this gets skipped, this gets skipped, so it goes to here. So it's 85. upper hand of 85 is 75. There needs to be. So how do you know? How do you know when to exit with the very last one? Let's see what does the book say on the cheat. I don't know, that's strange. I'll just cut it off from here.